Welcome back, mathematicians. In this video, we are going to work with the parabola conic section with the vertex at the origin 0, 0. We have two equations where we will be asked to find the directrix, vertex, focus, and endpoints of the latus rectum, and then we will graph each parabola. Our first equation is x squared is equal to 4 times y, and our goal is to first determine whether the parabola opens up, down, left, or right. Because of the fact that the x variable is the squared term, we know that the parabola opens up or down. And because of the fact that the coefficient to y is a positive 4, we know the parabola opens up. We should now identify the general form of this equation because, or based on, the fact that it has a vertex at the origin 0, 0, and it opens up. That would be x squared is equal to 4a times y. Because the coefficient in our equation is a positive 4, we know that 4a is equal to a value of 4 in our equation. Solving this equation for a, we get a is equal to positive 1. A represents the distance from the vertex to the focus and the distance from the vertex to the directrix. Let's start with the vertex, which we know is on the origin because it's stated in the heading, and also because there is not a horizontal or vertical shift. Because the parabola opens up, the focus will be 1 unit above the vertex. That means that the focus has the ordered pair of 0, 1. The directrix will be 1 unit in the opposite direction, and we also know it's a line. Because of the fact that the line will not intersect the vertex or the focus, and it must be either horizontal or vertical, that means in this case it's going to be a horizontal line. We will use an equation to define that horizontal line, and the equation is y equals -1. Next, we need to find the endpoints of the latus rectum. The endpoints of the latus rectum in this case will be directly to the right and left of the focus because of the fact that the parabola opens up. Based on that information, we know that the endpoints will share the same y-coordinate as the focus. Our goal now is to find the x-coordinates. And so what we'll do is we'll replace the y variable with the value of 1 in the original equation. So it'll be x squared is equal to 4 times 1, and we'll solve that equation for x. We'll get x squared is equal to positive 4, and finally x is equal to plus or minus 2. So the endpoints of the latus rectum are going to be positive 2, 1 and negative 2, 1. Plotting that on the coordinate plane allows us to come up with the 3 points necessary to plot the parabola, and also allows us to know how wide or how narrow the parabola is. And so this is the graph of x squared is equal to 4 times y. Our second equation is y squared is equal to -12 times x. Let's first identify whether the parabola opens up, down, left, or right. Because the y variable is the squared term, we know it opens to the right or the left. Because the coefficient to x is -12, we know it must open to the left. Next, let's go ahead and determine or find the general form of this equation. Because it opens to the left and the vertex is at the origin, we know it is y squared is equal to -4 times a times x. Because the coefficient to x is -12, we can then set -12 equal to -4 times a and solve that equation for a to get a value of 3. That means the focus is 3 units away from the vertex, and the directrix is also 3 units away from the vertex. Because it's stated in the heading, and also because there is no horizontal or vertical shift, we know the vertex is at the origin 0, 0. Because the parabola is opening to the left, we know that the focus will also be 3 units to the left, which means that the focus has the ordered pair of -3, 0. The directrix will be 3 units in the opposite direction. However, the directrix is a line. It is a line that is either vertical or horizontal, but does not cross or intersect the vertex or the focus, which means in this case it's going to be vertical. Because the directrix is a line, it must be defined by an equation, and in this case it would be x is equal to positive 3. Next, we need to find the endpoints of the lattice rectum. Because the endpoints of the lattice rectum will be above and below the focus, that means that they all share the same x-coordinate of -3. Our y-coordinate is what we need to find. In order to find that, we will replace in the original equation the variable x with the value of -3 and solve for y. So we will have y squared is equal to -12 times -3. Solving this equation for y, we'll have y squared is equal to +36 and y is equal to plus or minus 6. Which means the endpoints of the lattice rectum are going to be -3, +6 and -3, -6. We now plot these points on the coordinate plane in order to have the 3 points needed to graph the parabola and also determine how wide or how narrow that parabola is. And so this is the graph of y squared is equal to -12 times x. Alright guys, good luck!